Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics Form 4 textbook question for Chapter 9 Solution Triangle Intensive Practice 9.3. So again, if you enjoy this video, kindly like, subscribe, or leave us a comment on how we can improve this video presentation. So let's get started with question number 1. Now this intensive practice is all about area triangle. So there are two formulas for area. One is half AB sine C, another one is Heron's law. So let's start with the first one. Now in this question, we're going to use half AB sine C. Now remember, let me go through quickly. When you are given the length of two sides of a triangle, you can draw any triangle here. A and B should be the length of two sides with angle C. We call it an included angle. That's angle that's flanked by the other two given side. So if I take A times B, I take the sine multiplied by sine C multiplied by half, I will be able to find the area triangle. Now in this case, your AB, maybe I label for you here. We are given area of ABC. The whole triangle is 18. So this is already 9. This length I do not know, right? And you're given angle sine angle theta is 203. So we can use half AB. A will be, let's say, 9. B will be AC, sine of the angle in between, which is theta. This area is now 18. Now we know sine theta is now 2/3, right? So when you simplify this, well, I just cancel this 3 AC equals 18. AC is just 6 cm, right? This is 6 cm. All right, now the next thing is we want to find area of triangle ABD. Now ABD is this triangle here, and in order to find this area, I think we have to take the whole triangle minus the green triangle here, ADC, to get the yellow one, ABD. So let me write down area of triangle ABD that we are finding is the same as area of triangle ABC, the whole triangle, the big triangle, minus area of triangle ADC. The big triangle is 18. We already know that it's given. The green one is half times 6 times 6 sine of the angle in between, in this case theta. So we can just, I think we can count this and call it, this is 18, right? This is just 18. Yeah, half times 6 times 6 is 30, just 18. Sine theta is 2/3. 18 times 2/3 is 12. 18 minus 12, your area is 6 cm. All right. Okay, the second one is quite interesting. You have a regular pentagon. Yeah, the length of side is 5 cm. You're supposed to find area of this pentagon. Now we know that a regular pentagon will look something like this. Yeah, sorry, my diagram is a bit ugly, and they all meet at the center, right? So now we know the length of side, which is 5 cm, but to use area triangle, we need more information. We need to know angle and the length of two sides between the angle, right, next to the angle. So I think we know, I hope you learned this in your Form 2 maths, right? Total interior angle, if I go one whole round, is 360. When you divide by 5 equal angle here, you will get 72. That means this is 72 degrees, right? But to find area triangle, I need more information. Although I can find this angle, I still need to know the rate, the length here. Maybe I call this x, and they are all equal length. They are all equal length. They are all isosceles triangle. So to find this length x, right, we have to use cosine rule first. Now remember cosine rule, the opposite length is 5, so you square it, equals to x squared plus x squared, the length of B and C. Yeah, if you can't remember, let me write down a squared equals b squared plus c squared minus 2bc cos angle A. Now your BC, they are both x and x. Cos angle between is 72. Now 5 squared is 25, no problem. This is 2x squared. Now this is a little bit annoying because you need to if I leave it in decimal, make sure you give more decimal point, because what I found is that when you use less decimal point, your answer may not be the same as the answer given in the textbook. So up to you. If you want to get a perfect answer from the textbook, right, so you should just write as many decimal as possible. So I'm going to write 2 minus 2 cos 72. Then I take 25 divided by answer. Now I hope you can do this mentally. I'll just type this in your calculator, and then 25 divided by this value. My x squared is 18.090, I think 02. This is good enough lah. Yeah, now you can square root it if you want, but when you square root, what happens is that you square it back, the answer may not be the same. Yeah, because we tend to leave it in, we tend to round this off. Now, if you want to square root it, make sure you use more, 4.25324, more decimal point. Yeah, okay. Now, to find area, now that I know the value of x, we know area of this whole regular pentagon consists of 5 identical triangles here. So each triangle has length of side AB, which is x and x. Can I write x squared? And the sine of the angle in between is 72. So I will write 5/2. Now, since I already know the value of x squared, I just substitute x squared with 18.0902, and then I take sine of this angle. That will be easier, better, right? If you want to use this, please use more decimal point. Yeah, don't take 4 point. I think if you take 4.253, also your answer is different from the textbook. Right? If you want to get exactly the same value, yeah, use more decimal point. So I'm going to key in my calculator, right? And what I've discovered is that my answer is the same, 43.012. Yeah, okay. Yeah, same as the textbook. All right, let's move on to question number 3. Mei Ling wants to prepare a greeting card in the shape of a triangle. The area of the triangle is 30, the length of two sides are 8 and 11. Right, so let's draw just a sketch, yeah, like this. This is 8, this is 11, okay, this angle theta, yeah. The opposite length, I don't know. Now they say find the possible length of the third side. So now why did they say possible? Because your angle theta can be acute, can be obtuse. So let's make it more obvious, okay? I make it more obvious. That is, I show you 2 possibilities, because we know that from ambiguity, we can have, maybe I make this shorter. This is theta, 8, this is 11. Now you can also have something like this. This is theta, this is 8, this is 11. So this is x, or this x, the length of side that you're finding. But theta can have 2 possibilities. Can be acute, can be obtuse. So when you use the formula half AB sine C, sine CC is theta, the result is now 30. The area of the card is 30. So sine theta is 30 times 2 divided by 88. I got 15/22. Now you don't have to write this down. I just want to show you that theta can have 2 possible values. When you shift sine 15/22, you get 42.99 if it's acute, or if it's obtuse, then we take 180 minus 42.99. I've got 137.01. Okay, so if theta is acute, then my x squared is now, we use cosine rule now, x squared is what, 8 squared, 11 squared, which is b squared plus c squared minus 2bc cos angle theta, 42.99. And use your calculator, square root it, yeah, 7.501. Now, if theta is obtuse means more than 90, so we'll take x squared equals to 8 squared, 11 squared, 2, 8, 11 cos 137.01. Again, use your calculator, square root it. I've got 17.713 cm. All right, okay, it's not difficult, right? All right, moving on. Yeah? Next question, question number 4. The length of side of a triangle is 3x, x minus 1, 3x plus 1. Given that perimeter of the triangle is 63, calculate the area of the triangle. Okay, now this one you have to use Heron's law, right? But first of all, let me just draw or sketch for you. So your triangle, I just do a rough sketch. I don't know how it looks like. This is 3x perhaps. This is a x minus 1, and this will be 3x plus 1, yeah, something like this. Now you're given the perimeter, so if you know your perimeter, we can find the value of x. Yeah, perimeter is 63, so 3x plus x minus 1 plus 3x plus 1 is 63, so this will be 7x equals 63, x is just 9. If I know the length of x is 9, so let me just sub inside. Okay, it's a bit ugly. So if this is 9, 3 times 9 is 27. This will be 27 plus 1, 28. 9 minus 1, this is just 8. Yeah? So the length of side is given. So when you're given length of all three sides, actually there are two ways to do it. You can use Heron's law, you can use the half AB sine C. But to use half AB sine C, you need to know at least one angle. You need to find, let's say, one of these angles first. Right, so I think the question one tests you your understanding or your knowledge on using Heron's law. So I'm just going to use Heron's law here. So number one, we find our S, which is your semi-perimeter. So we know the perimeter is 63, right? You just divide by 2. Okay, so you will get 31.5, right? And your area will be, remember, if you are not sure, the formula is given by S minus A, S minus B, S minus C. ABC is your length of side. So your semi-perimeter S is 31.5. So we take 31.5 minus your A, maybe I write 27 first, 31.5 minus your B, which is 8, 31.5 minus your C, which is 28. Whatever you get, put a square root over and calculate this. Yeah, one shot. I do it one shot in your calculator. 107.977 cm squared. All right. Moving on to question 5. Okay, so here Pooja fence up a plot of land in the shape shown in the diagram. So now the measurement BD is 5, BC is 7, CD is 8, AE is 12, AE is 12, and BDE, ADC are straight line. Calculate area of the fence. Okay, now to calculate the area fence by the Pooja, so we are finding the area of the whole thing. But how you want to find it is up to you. So I think the way I see it, we can use, we need more information, we need an angle, right? Because I think if you look at this triangle, okay, let me highlight for you. This triangle we can use, Heron's law, no problem. But the bigger triangle here, right? We don't have enough information, we don't have the length of DE, right? So I think it's best we find one of the angle first. Okay, maybe I focus on triangle BCD. Yeah? Why? I find this angle first. Let's do some planning first. I will find this angle. So once you know this angle, we can find this angle, right? And once you know this angle, we can find, let's say, the length of this side. Correct. And once you know the length of this side, you can, now I know some people may want to find one by one, but I don't want to find one by one. I think it's best we just take this whole thing. So basically, we're finding area triangle ABE plus area triangle, maybe I make this darker, a bit hard to see, area triangle BCD. So I find this full triangle. Okay, let's start with BCD. Now focus on triangle BCD. I'm going to use cosine rule, the second version, to find angle BDC. Yeah? So remember, for those who are not sure, we can use cos A equals to B square plus C square minus A square to BC. We use this when you're given the length of all three sides and you're finding one of the angle. So B and C are the length of two adjacent sides. Angle A is your included angle here. In this case, your opposite is 7, so your small a is 7. So I'm going to write 5 square plus 8 square minus 7 square. Divide 2, 5, 8. Use my calculator. This is cos angle BDC. BDC, and angle BDC is 60. Now, if this is 60, the opposite side is also 60, right? And if I know this is 60, I think we can find this angle here. Yeah, this angle will be 80, right? Angle DAE. Okay, let me write down. Angle DAE is 180 minus 60 minus 40 equals 80. And if I know this 80, I can find DE. So we use sine rule to find DE. DE divided by sine 80 equals to 12 divided by sine 60. My DE is 13.646, right? So this is now 13.646. Okay, so to find the area of the fence, basically we're taking area triangle BCD plus area triangle ABE. Now, for ABE, you need to find what is BE first. BE is 5 plus 13.646, which is 18.646. Yeah, don't even write this down. Yeah, too simple, right? Now, area BCD, don't have to use Heron's law because I already know the length of two sides, B and C. I know, A and B, 5 and 8, and I know the angle in between. So I'm going to use half AB sine C, 5, 8 sine 60. For the second one, ABE, I'm going to take half AB sine C as well, 12, and this will be the 18.646 sine of the angle in between, which is 40. Just calculate this one shot. Use your calculator. I got 89.233. Okay, this is in C. This is in meter, not cm. Yeah, meter square. All right. Okay, let's move on to the next one. Yeah. Okay, it's probably the last one. Now, diagram shows a decoration rack in the shape of a triangle EFG. Given that FG is now 15, EG is now 16, EF is now 17. Find the height of the rack. So in many ways you can do it. You can use half AB sine C and half times base times height, or you can use Heron's law, compare with half times base times height. Because you're finding height of the rack will be here. Yeah, so it's best to use half times base times height, right, to find H. But you must first find the area of triangle. So area using Heron's law, I'm going to use Heron's law, find our semi-perimeter, which is what, 15, 16, 17. Divided by 2, I got 24. My area will be 24. 24 minus your first length, 15. 24 minus second length, 16. 24 minus third length, 17. Put the square root over, I got 109.982. Okay, this is in cm squared. Now, then we use half times base times height. Your base is now 15. Your height is now h. Yeah, and the area is the same, 109.89982. Okay, use more decimal point if you can, just in case. Otherwise, your answer might be different. You calculate this, and I got my height to be 14.664 cm. Right, this is in cm. All right. Okay, so that's the end of this discussion. So again, if you enjoyed this video, kindly like, and also just so you know that we have a collection of learning modules. This is our workbook collection, modules with videos, with exercises, with topical practice, past year question, drill practice. You can get in touch with us to find out more. Visit our website, WhatsApp us, or you can even order the books directly through our Shopee account. Pusat Tuition Teliti, search for it here in Shopee, right? Thank you for watching this video. Hope to see you in the next video.